Hi everybody. So today's video is going to be about task 2.3, which is our third task for module 2. We have two important learning targets today. The first one is I can identify if a relationship is linear or exponential and support my reasoning. So this has been one of the big new ideas of this module is determining if we have a linear or an exponential function and then explaining how we know. Now, the second big idea of today is going to be I can identify key features of exponential and linear equations and interpret them in the context of a problem. There are two pieces to this learning target, really. We're going to be identifying key features, and our key features today are going to be the constant rate of change, which we also call the common difference, or the constant ratio, which we also call the common ratio. So what we're going to do on this page is sort of summarize what we know about determining linear versus exponential functions. So for each of the different types of representations, so using a graph, using a table, using recursive or explicit equations, we are going to practice explaining how we would know if that's linear versus exponential. And we are also going to practice identifying the common difference or the common ratio based on that representation. So let's say that I give you a graph. If your graph makes a straight line, you know that you have a linear function. So if I saw this graph, I would say this function is linear because the graph is a straight line. Now let's say we saw a graph that was a curve instead. So in this case, this would be a continuous function that is curved. We would say then that this function is exponential because the graph is curved. Now, the key here is that when you're talking about a graph, you can totally talk about the shape. So is it straight or is it a curve? However, when we're looking at a table, we can't talk about whether it's a straight line or it's curved because we don't have a picture. So we need a different technique to figure this one out. When we're looking at a table, the technique that I would use is I would find the pattern. Now, the pattern in this table would be subtracting 2 each time. Because this is a subtraction pattern, I know that this is a linear function because this is an arithmetic sequence. So I would say that this function is linear because the sequence is arithmetic. Now, the key here is you'll notice I did not say because the graph makes a straight line because it doesn't have a graph. I can't talk about it that way. I need to be specific that this representation is telling me about the type of sequence. In the second problem here, I can see that the pattern is dividing by 3, or I like to write that as multiplying by 1/3. So if I notice that the pattern is multiplying by 1/3 or dividing by 3, I can say that this is an exponential function because the sequence is geometric. You'll notice again, I didn't mention a graph here because I don't have a graph. I need to talk about the pattern and the type of sequence that I have. In the next problem, we're going to be given some recursive equations. The key here is going to be to look for the pattern. Now you'll notice that the pattern here in a recursive equation is always at the end of the equation. So since this is the pattern, it tells us what type of sequence and therefore what type of function we have. Since this first one is adding 5, I would say that this is a linear function because the pattern is adding 5 each time. And since the second equation has a multiplication pattern, I would say that this is an exponential function because the pattern is multiplying by 5 each time. Now again, the key here is I didn't talk about whether it was a straight line in the graph or whatever because I don't have a graph. I need to talk about the pattern because that's what I have in this problem. In this one, I talked about the pattern because that's what I know from this problem. And last but not least, what if we have an equation? So an explicit equation, I apologize, an explicit equation. In an explicit equation, we always have to look by the x to determine the pattern. In this case, because there is a multiplying by 2 here, that would be the pattern in this problem. In this case, because there's a multiplying by 7 here, that would be the pattern in this problem. So in the first equation, I would say that this is linear. And I would know that because the equation does not have an exponent. So I'm linear because I do not have an exponent. Whereas in this equation where there is an exponent here, I would say that this is geometric because the equation, I'm sorry, not geometric, exponential. That was my bad. Exponential because the equation has an exponent, which is where the name exponential comes from. It's exponential because it has an exponent. Now, the last thing we need to do here is I want to look at where you can see the common difference or the common ratio in the problems. So in a table, the common difference or the common ratio is always the pattern. In an equation, the common difference and common ratio is whatever you are doing to the previous term for a recursive. In an explicit equation, the common difference or the common ratio is always the number that's attached to the x. And we can see that over and over and over again here. Kind of that this is the same thinking in each of these different representations. All right, what we're going to do next is we're going to try some practice problems. So for these problems, we're going to be asked to do two different things. First, determine if we have a linear, exponential, or neither for our equation and support our reasoning. And then second, identify the constant rate of change, which is also known as the common difference, or the common ratio if applicable. So as a reminder, the constant rate of change is the same thing as the common difference. And the constant ratio is the same thing as the common ratio. So let's try number 1. Based on this equation, I can see that there is an exponent in the equation. So I am going to say that this is an exponential function, and I'm going to say because the equation has an exponent. Now, because it's an exponential function, that makes it a common ratio. So I'm going to have the common ratio, which is always going to be the number that's by the x, the base of the exponent. In this case, that would be 2. For problem number 2, I notice that there is no exponent in the equation. So I would say that this is a linear function because the equation does not have an exponent. In this case, because it's linear, we would say that we have a constant rate of change, so a common difference. And it's, again, always going to be the number that's by the x. In this case, we are adding 2 to our numbers each time. I should have noted that this is multiplied by 2. For problem number 3, we have a recursive equation. So based on this equation, I'm going to look at the pattern. The pattern here is that I'm subtracting 7. If we have a subtracting pattern, we're going to say that this is a linear function because the pattern is subtracting 7 each time, which means we're going to have a constant rate of change because that's the same thing as a common difference. And our constant rate of change this time would be minus 7. In our next recursive equation, we have 4 times f of n minus 1. You'll notice that that's written at the beginning here. So this is our pattern. That means that this is going to be an exponential function because the pattern is multiplying by 4 each time. And that means we have a constant ratio of times 4. Okay, the next part is that after you can find all these things in an equation, we need to be able to interpret them. Interpreting a common difference or a common ratio means telling me what it means in this story. When you're interpreting, there are 3 pieces to what you need to include. You need to include what is changing. So are you measuring the height of a ball or how much money is in the account? You need to include how much it changes by. So be specific. Is it multiplying by 2? Is it adding 2? Is it subtracting or dividing? And then you need to include how often it changes. So is it changing every month? Is it changing every week? Is it changing every year? We did this in Module 1. So as a review, here's a type of problem we might have seen in Module 1. It says Samantha is practicing for a recital. On the first night, she practices for 5 minutes. On the second night, she practices for 15 minutes. On the third night, she practices for 25 minutes. And then if you skip a few on the 6th night, she's going to study for 55 minutes. Based on these numbers, the pattern is 5, then 15, then 25, which means I'm adding 10 each time. That means that I have a common difference whose value is plus 10. To explain the meaning, I just have to tell what that plus 10 means in this problem. It means the number of minutes she practices increases by 10 how often each night. So I included here, what am I measuring is the number of minutes she's practicing, what's happening to it, it's adding by 10, how often each night. Those are my 3 pieces of my explanation. Now we're going to do the same thing in this chapter. So Kylie made a new TikTok video on Friday. The equation below models the number of views on her video, where v of x is the number of views after x hours. So based on this equation, this is going to be a linear function which means it's going to have a common difference. And that common difference is always going to be the number multiplied by the x. In this case, that would be 20. Now in this unit, instead of calling it a common difference, we're going to call it a constant rate of change, which is the same thing as common difference. And we would just say 20 is the value. So it says here, Kylie made a new TikTok video. The equation models the number of views on her video. So we are looking at the number of views on her video. To explain the meaning, we would say the number of views and then what's happening to it is that it's increasing by 20 because that's the common ratio, the common difference, the constant rate of change. How often? It tells me in the problem that x is measured in hours, so it would be each hour. For problem number 6, it says 500 gallons of water were in a pool at the end of summer. As the pool is being emptied, each hour there is half as much water as there was the hour before. Now, if I read this again carefully, it says each hour there is half as much water. That means that we are multiplying by 1/2. So this is going to be an exponential function. It's going to have a common ratio. And the value of that common ratio is going to be 1/2. So I'm going to circle common ratio. I'm going to say times 1/2 because that's the value. To explain the meaning, we have to talk about what we're measuring. So we're measuring the amount of water in the pool. So we would say the amount of water and then what's happening to it, we would say is multiplied by 1/2. How often? It says each hour. So each hour. And that's it. Thank you guys so much for watching, and I will see you soon for some practice.